that is very inherent to our human life, human body, human behavior. But the detecting it or exactly putting that into certain form isn't that easy. That's the idea. So basic emotion theory, there are a lot of that one. Actually, while doing this research, I just happened to have the psychologist who's a specialist in emotion. After talking to that lady about the day and a half, I gave up because the theory gets so complicated and so complex. Different theories are found, and so I asked what is the basic emotion that we can say a basic component. Oh no, there is no basic emotion. Everything is different. Different person can say differently. So after so different person says differently what is a fundamentally emotion and what is the how we include it. So after this complex, forget it. We'll have go easier way. That is okay. Basic emotion is 6 emotions. That's more or less an agreed one. Anger, this right. Then disgust, fear, like the one you have. Then happiness and joy and sadness. You may say happiness, joy may be similar. Anger and disgust may be similar, something like that. But according to the psychologists, that they are quite different emotions. So again, that anger, disgust, fear, happiness, joy, and sadness. Why in this order? It's alphabetical order. So anyway, so then there's one more emotion. Anybody can think about? No emotion. Yeah, that's a neutral emotion. So sometimes you have no feeling. You just kind of a matter of fact. Just a certain event happens. Okay, I don't care. Well, it doesn't give me any feeling. Neutral happens to be a very important control point so that we can migrate from one emotion to another emotion and another emotion. So anyway, anger, disgust, fear, happiness, joy, sadness. That's a surprise. Oh yeah. So then some people put this a surprise as the one more emotions like that, but usually it's 6. So here, happy, sad, surprise, fear, anger, disgust. This is the what they say basic emotion. Sometimes you drop one or add one more, things like that. So that's universally agreed the emotion by many researchers. So in computer field, even if the computer doesn't have feeling, doesn't express any emotion, but there is thing called emoticon. I'm sure you have used it in the email or in some messages. You have certain symbols or character arrangements that gives you some kind of the feeling. You can usually agree. So something you are astonished, or this is neutral, and melancholy and joy, all kind of this emotion. So it's first Scott Feldman of Carnegie Mellon University in '82, this a long time ago, that first proposed. That's the year I started teaching at the Cal Poly, so it's a long time ago. And then there are many variations, and then emoticon, there are a whole bunch. I didn't know there are so many of emoticons. So this is called emoticons. So this is smiling, laughing. Looks like he's laughing, isn't it? And then this he, like, hey, like that. So they have nothing else to do. Maybe it's a sit down and try a different combination. And that I don't know what is a full glass, and my glass is full. This one is in a way symbolic, but it's the kind of emotion that's satisfying, but not facial emotion. That's the idea. Then there's a sad, unhappy, it's a frowning. Like that. So I had a whole list of this kind of dictionary of emoticons, and turned out to be there are quite a few interesting ones, and some of them. Tearful, is that tearful? Crying? I don't know. Crying, maybe. Crying and really sad, something like that. So there are a whole bunch of this emotion, but it is really a matter of the injecting some of the human emotion into kind of the mindless, tasteless sentences. So there's a sad, unhappy, and surprise, happy, and the angry, sarcastic, and there's others as oops, indifferent, so on, so like that. So there are quite a few. The point of the matter is that there has been a lot of effort to put some human emotion. So very often that you send an email and the message is a little techy, a little bit there's a chance of the other opposite, the member or the receivers have somehow offended. In the case that with some the emoticon, I don't know, there's usually put a smile and say, oh, I don't mean to hurt you, just the way expression is like that kind of thing. So emoticon helps really. If you use too much, you feel like that's not really good sentences either. So there's a little the moderation necessary. And then you heard about this smiley. Often that I just want to make sure that smileys are the patented registered symbol. So the guy named the Franklin Lafrani of France, he invented and then they made this kind of sequence of these symbols with the full face and called the smiley. So there are a lot of these symbols like in Yahoo Mail or the Google Mail that allow you to use the smiley on the message. That's more expressive than this the emoticons, because emoticons are using printing characters, but this one is actually graphics, so it has more chances. Now, the famous painting by this known as Mona Lisa, and everybody they said, or the people over the history said, oh, that's a mystic the facial expression. Obviously, she looks like smiling, but at the same time, in some sense, it's somewhat different. So actually, this is something that I want to revisit, and this Leonardo da Vinci's work actually is we were told that that's he himself is the model and put into the lady's form. But what kind of facial expression does she wear? That's the kind of believe it or not, the interest of a lot of the researchers and a lot of PhD theses came out with things. So that's interesting. So they tried to kind of change the face, sort of the push-up, the little bit, the changing of their faces, their eyes and mouths, and made a different kind of the expression. But the difference is so subtle that it's a little hard to agree on. But let's continue on with this. So anyhow, there's a certain researches that the smiling and they can kind of simulate whatever emotion to the Mona Lisa faces. And then, so the main point of today's presentation already had the context. But detection of emotion by, so I had quite a few graduate students. I got about 50 students in my name, but I decided to work together as a kind of a series of emotion detection. One is by, well, we detect the emotion by the facial expression. That's the most obvious and clear signal for the emotion. Then also from the written test, and then also from spoken voices. So there's a telephone calls and someone saying something, and it looks like it's just a common conversation or just a little bit of informative message. But nevertheless, what if that is inside there is a latent emotion of a very strong anger or happiness or joy. So there's by facial expression and the written text, and then by spoken voices. That's the series. And then, of course, that research is not complete. I mean, we have done on this one, but there are more to be done. So facial expression is done by multiple stages. So the detail may be a little too hard to understand, but collect a lot of pictures from the web. So then we had a bunch of people. They sit on the camera and they say, okay, you smile. Just have the facial expression, happiness, or joy, or surprise, disgust. So all different kind of, then as much as possible, don't move your face, but just change your facial expression. So obviously there are quite a few collections. Also on the web, there's the computer vision database site that is mostly done by the MIT and Harvard University at the collection of the human faces. So we used those, and then started isolating different parts of the faces. So eyes, eyebrows, and then mouth and the nose. But nose doesn't change. It doesn't contribute much on the facial expression. And the ear doesn't change, so it doesn't contribute anything. But obviously eyebrow and eyes and mouth. That's the three components that actually makes all those differences. So we have digitized from a certain model that is happiness, sadness, and surprise, fear, anger, disgust. Then from the recognition, the technique they are already known, that you start to digitize the face, that you get all those differences like that. On these days, you go to the airport, and there's a camera and facing you. So if you are a criminal, then they will detect you right away there with your face, unless you keep disguise. So obviously, the main thing is that the feature extraction, is the outline of the face, including the chin and the mouth, ear, nose, ear, and eyes and eyebrows, and you isolate that one into some kind of a line curve. You would say feature expression and the thin. So this line is boiling down to say things like that. So we have, after the analyzing so many data, we could have, in a way, that so it is more of the a priori or the Bayesian statistics thing. I'll talk about that in speech thing, but there that after the fact, so to speak. Okay, this is identified as angry face. Okay, from that angry face, what are the general patterns? From happy face, there are 10 of those, 100 of those. The angry face, how is the facial expression? You may say, oh yeah, different people have a different way of expressing the anger, but from outside the look, that we say that angry face, you know it. Especially between husband and wife, then you know that your spouse is angry or not, right? My wife knows that I'm trying to say anything. So anyway, so that kind of detection, so we generalize that one into so-called parameters. So there's the control points for each curve. It's not straight line. So each curve has a certain control point, and then there are a lot of the graphics technique, especially we use this Bezier method that actually regenerate into the smooth curve. So after this extracting and matching it up, that you say this is an angry face, this is the happy face, things like that. So this picture more or less become somehow thinned out into basic of this. So happy, obviously we agree this is a happy face, this is a sad and surprise. Mostly is the mouth, but also eyebrow is different. And then angry, because mostly the anger comes out of those the eyebrows, and then fear is somehow that big eye and open up eyebrows, things like that. So then disgust is somehow your eyes, the mouth got crooked, and then the eye level becomes somehow the different with eyebrows and on the level, things like that. So after analyzing so many data, the actual pictures, we could come up with those. So once we got this control points, there's control points in here, then you can regenerate into the curve using there are many different techniques, one is Bezier, B-spline, overhouse, or with 4 or 6 control points like that one. But turn out to be the Bezier method is the most frequently used one and works best in here. In case you did in France, that there's a Renault car, the car named Renault. The Bezier he died. It was the engineer, the design engineer on the Renault. And he did when having curvature of the car body or the bumper, then he used this kind of technique. From control point and based on control point, you can stretch in and out and interactively decide the shape that you want and finalize it, things like that. That's how it went. Then Catmull-Rom is the little more generalized method that actually includes the Bezier and Oberhauser. So that method alone is not enough. So we had a kind of combining function that is by changing the C value from 0 to 0.5, that is about halfway, 0.3 is about the Bezier curve and 0.5 the Oberhauser, things like that. So you can make this curve very smooth or very straight, something like that, with angled like that. So some car comes with an angled the body design, some of them very smooth and round shape. Those things can be done in here. And in computer graphics, this the curve generation is a very standard form. So again, digitizing that with the eyebrows and regenerates over and a whole bunch of data. Again, I'm not going to go in detail about that one. But so we created some kind of the simulation program goes from here one face, the facial expression to another facial expressions. You migrate that one. So you have one person's, like for example, Hitler's face. Then he is usually very angry, but let's make him very happy. So somehow we can change his face or disgusted. That's a pretty frequent expression for you, I guess. So you can kind of simulate in an animated form. This is also very useful in combining different emotions and has a lot of usage in animation industry, movie making, things like that. So from this somehow angry face to surprise face, right? So you can migrate it. This one, so-called the parametric equation, that kind of the in-between, that when you see the level that was like a Terminator, then there's the human becomes some kind of a car become the monster become the knife, things like that. That you change from one shape to the other in gradual form. So that's what we did as a kind of smoothing in between methods. So doing that like that. So we had a different emotion to another emotion kind of things. So the idea is that once we have done, then you have somebody's face. This one gentleman standing there, I take a picture, analyze it, and he's pretty angry now because he didn't see it, something like that. So some kind of emotion we can detect. That's the idea about this. So using these techniques, someone else did it, but the Mona Lisa happens to be 83% happy because of those in-between method of percentage, and the 9% disgusted, 6% fearful, 2% angry. Judge it for yourself. Is it true? But obviously, somehow a happy face with some smile, but somewhere, someplace with the mouth shape, something disgusting. And a little fearful, maybe on how to buy. So anyhow, this is the analysis that done, and we could match similar values over there. So something like that. How about this? This maybe the 100% happy, I don't know. But so anyhow, you can change the facial shape by using those techniques. So computer, the software these days that everything's so fast. So using this my 10-year-old laptop, I could simulate in real time. So these things are getting very feasible to implement. So anyway, that way that again we can detect the human emotion from the existing data. But of course, that to do that we got to work on with so many the sample data. So it takes some time. We can't do all, but it's analyzing it and knowing that this is a kind of angry face that we will analyze the facial shapes, like the eyebrow, the eyes, and the mouth. That's most contributing factors. I don't know what this gap is. Okay, so that's the first one, and of course that this can be used for the detecting some emotion. But Usually people may say, oh, don't worry about it. I don't need a computer. If someone's face is very angry, I can see it. So maybe computer is less useful in here. It's so obvious to the human. But how about from written things? So the customer service call center has receiving several calls, and obviously that the emails. And then, that obviously that this one is something out there we got to be concerned about. Certain usage of the words, certain usage of the order of certain sentences that gives out some kind of emotional state of that person. Whether you say English major people may say better than I do, but somehow that has been known. And then, so the computer-mediated communication, that one is that what it is actually faster, freer format. But that is that when often once in a while that you have when you have the customer service, somebody's saying, but it's not quite human, but it's almost like a human. That's machine generated. But you don't want to make that one message just the robot. That's not a good idea. Or a very high-pitched, angry tone. That's not a good idea. Can we make this more pleasant, happy tone? Something like that. So that kind of computer-mediated communication gives the chance to a tool to make our simulated or synthesized voice be very much pleasant and expressing certain emotion. So for example, that I want to send out certain message, but I don't want to reveal my voice, but I say I'm going to be very angry. You can generate that angry tone and send it over. They wouldn't know it's me, but at least they got a message. That's the kind of idea. So while you are operating the certain machine, phone, or the operating certain machinery, typewriting, the secretary is typing all day long, and say something, or they started writing some the message, private message to her or his friends, and the message, even if that we don't see well, but inherently there's a certain very strong emotion stored in here, and we want to know about it. That's the idea here. So in here that the facial expression kinesthetic, we actually that one done by the kinetic gesture is also very important, and acoustic, the voice is important, but the text pattern is very important. So we would like to go there with that. So, oh, be quiet, go play by yourself. This kind of a sentence you put in. Of course, that usage of this exclamation mark gives out some emotion, but this one is kind of ordering. It's not definitely happy tone. So the certain sentences are somehow showing or giving out the emotion. Of course, that it is very difficult to do this one by this written form. So what did I do wrong? In the case that it may be some kind of disgust or surprise, that kind of feeling. It depends. So we make a mistake. You as a supervisor want to kind of teach some lesson to your subordinate. In the case, how would you do it? Very kind of nicely, without offending that person or discouraging that person. So in the case that we write the letter, frequently that whether it's in English or any other languages, between the lines there is a certain emotion stored in here. The question is how to detect it or how to identify it. So that was much harder. The facial expression is rather easy because we can easily verify it. But this the messages that is hidden message between those things are not that easy. So we ended up using so-called hidden markup the model. That hidden markup is a little bit complicated model, but on the back of a certain the process of certain changes, there is certain model. So based on that model, what kind of probability would result in certain kind of outcome. So having the outcome, and can we trace back the causes? Usually we got the causes or the reasoning, and then the consequence we can get. On